Now we need to do problem 6 and 7, and this will finish up the test review. The demand equation for monopolist product is that P is the price per unit in dollars, Q units are demanded. Find the value of Q for which revenue is a max. So we need to take our revenue function and find a maxima, basically a relative maxima. So that would come from first derivative. First, though, we're given our P. They're asking about revenue, so we have to find our revenue function. Since R equal PQ, let's fill in for the P and multiply it times Q. So our revenue function will be 2700Q minus Q cubed. I kind of messed that up, didn't I? Okay, that's how we start. All right, so take derivative, always derivative, so that would be 2700 minus 3Q squared. Set it equal to 0 and find our critical point. So let's factor out the negative 3, and we'll end up with Q squared minus 900. Let's factor that. That is the difference of two perfect squares. So Q minus 30 times Q plus 30 equals 0. Our critical value here would be positive 30, because Q minus 30, if we set it equal to 0, Q will be positive 30. We're not really interested in that critical value, which would be negative 30, because we're dealing with quantity in a revenue function, so we're only concerned with the positive Q values. Our interval will be negative infinity, nope, it'd actually be 0 to 30 and 30 to positive infinity. So if we have a test value here, we could use 1, would make it really easy. What is our first derivative in this interval? So if you want your visual from 0 to 30, let's check this interval. So we have a negative 1 minus 30 is negative, 1 plus 30 is positive. So we're actually increasing from 0 to 30. My revenue would be decreasing, I believe. If we have a test value here, we have a negative factor, a positive factor, another positive factor. So my revenue would be decreasing here. So 30 is a relative maxima. What is the maximum revenue? Well, if I know I have a maximum when Q is 30, we can find our revenue by placing 30 in for Q into our revenue function. So 2700 times 30 minus 30 cubed. And according to my calculator, I would have 81,000 minus 30 cubed. So minus 27,000. My revenue would actually be 54,000. $54,000 when Q is 30. Remember, we can find our max and min where it occurs, and then you plug in that max or min to the original function. In this case, we're talking about revenue, to find what revenue will be when Q is 30. Let's move to our last question, which is the hot dog stand. Our cost function is given where X is the number of hot dogs sold. So X is actually Q, quantity, and C of X is my cost. Determine where my graph is concave up, where it's concave down, and in the inflection points. Second derivative tells us about concavity. My cost function, let me just write it over. And I need to find concavity. First derivative, we'll just scoot right through and move straight to our second derivative for concavity. 12x minus 42. Set it equal to 0 and factor out a common factor if we can. You don't have to factor anything, but it's easier if you do. So we'll factor out a 6 and have 2x minus 7. If we set that 2x minus 7 equal to 0, our critical value will be 7 over 2. I'm not sure how we can produce 3.5 hot dogs, but we're going to roll with it because the problem still works out. Where is it concave up? So I've got 0 to 7/2 to infinity. And my second derivative, a test value, let's just say of 1, would be negative. So I'm concave down on the way up to 7/2. After 7/2, let's just say a test value of 4. That would result in a positive second derivative, so it would be concave up after 7/2. What was the original question? Concave up, concave down intervals. So this is my concave down, and this is my concave up interval. Any inflection points? Yes. The inflection point would be when x is 7/2 because our concavity shifts. It changes from down to up. So we have a point of inflection at 7/2, and our point of inflection would be, we need to plug the x value back in to our original cost. If we plug 7/2 back into our original cost function, 177 over 2. So this would be our actual point of inflection for this cost curve.